Hello everyone, and welcome to another video in my channel. In this video, we have a very nice logarithmic equation to solve. We are given log to base 3 of x all to power 2 minus 68 log to base x of 3 is equal to minus 1. We are told that x is a member of the set of integers. We are asked to find x. Before I proceed, I would like you to do me a favor. Please like this video, subscribe to my channel if you haven't done so, and as you subscribe, please turn on the notification bell so that you will be the first to be notified each time I upload a video. I would also like you to share this video to your loved ones. And also, I would like to read your comments in the comment section. Let us now solve the problem. We are going to apply some laws in logarithm to solve the problem. One of the laws we are going to apply is the reciprocal law, and it states that log to base b of a, for example, is equal to 1 over log to base a of b. Why are we applying this law? If we look at the bases, we see that the bases are different, and also the arguments are also different. However, we can make the base and the arguments the same in both cases. For that to happen, we'll apply this law, since the base and the argument switch position in the law. So applying this law, we'll have log to base 3 of x all to power 2 minus 68. Now this becomes 1 over log to base 3 of x instead of log to base x of 3 as we have it originally, equals to minus 1. Let's remember that this is a quantity. Let's log to base 3 of x equals to a. So if I substitute a for log to base 3 of x in the original question, I have a to power 2 minus 68 times 1 over a is equal to minus 1. To clear this fraction, we will now have to multiply through by a. So if you multiply through by a, here becomes a cubed minus 68 times 1 over a times a equals to minus 1 times a. This and this will cancel out, remaining a to power 3 minus 68 is equal to minus a. Let's now move this term to the left hand side. Plus a minus 68 is equal to 0. Looking at this polynomial equation, we can see that a term is missing. That term is the term with a to power 2. Also, if I put a is equal to 4, I am going to get 0. So 4 to power 3 plus 4 minus 68 is 0, because 4 to power 3 is 64 plus 4 minus 68 will give us 0. So a is equal to 4 in the first case. That means the first solution to this polynomial is a is equal to 4. Let's now find the other solutions. To find the other solutions, we need to divide the polynomial a to power 3 plus a minus 68 by its factor. Since a is equal to 4, a minus 4 is now a factor of this polynomial. So let's divide this polynomial by its factor, a minus 4. And we will do the long division method. Here we'll have a to power 3 plus a term is missing. That term, remember I said, is the term with a to power 2. We are going to find that term as we divide. Then plus a minus 68. Let's remember we are dividing by a minus 4. Now, a cubed divided by a will give us a to power 2. A to power 2 multiplied by a will give us a to power 3. Now a to power 2 minus 4 will give us minus 4a to power 2. Now if we subtract, this and this will cancel out, giving us 0, and this becomes plus 4a squared. So this is the missing term. Let's now bring this term down. If we bring it down, we continue with the division. 4a squared divided by a will give us 4a, and 4a times a is 4a squared. And 4a times minus 4 is minus 16a. Let's subtract. If we subtract, this and this will cancel out, remaining 17a, because a minus 16a is 17a. Let's bring this term down. This term is minus 68 and still divide. 17a divided by a is 17. 17 times 17 is 17a. 17 times minus 4 is minus 68. So the remainder is 0. Now, this is the remaining factor of this polynomial. If we now equate to 0, we have a quadratic equation. We cannot factorize this quadratic equation because if we check the discriminant, which is b squared minus 4ac, we are going to get a complex number. Now, b squared is 16. Then 4 times 1 times 17, because c is 17, a is 1, and b is 4. We have minus 52. This discriminant usually stays inside the square root sign. So we have plus or minus b, and this is the formula method. Now, I was saying that this discriminant, the value here is minus 52. So we have a complex number. So minus b becomes minus 4 plus or minus. We have minus 52 here over 2 times 1 is 2. These two solutions to the equation will be rejected because we are told that x is a member of the set of positive integers. And so a is equal to 4. Let's remember that log to base 3 of x is equal to 4. So 3 to the power 4 is x, and x is equal to 81. If we back substitute 81 for x in the original question, we are going to get minus 1. Let us try it out. Log to base 3 of 81 all to power 2 minus 68 log to base 81 of 3 is equal to minus 1. We want to find out. 81 is 3 to the power 4. So I'll apply power law here. Here is 4 log to base 3 of 3 all to power 2 minus 68 times 1 over 4 log to base 3 of 3 is equal to minus 1. What I applied here is the power law when applied to the base, because if I have log to base a of p of b, it will be 1 over p log to base a of b. This law is applied here, whereas log to base a of b to power p equals to p log to base b of a. This law is applied in the first case. Therefore, 4 to the power 2 minus 68 over 4 equals to minus 1. 4 to the power 2 is 16. Now, 68 divided by 4 is 17 equals to minus 1.